Hello guys. I've been playing with this pulse forming network and reading about them, and decided to put one together here that I'm going to show you in a minute here. This is pretty much the setup, just a bunch of 7 stages here, and driving it just with the signal generator, 5 volts square wave, and on the scope we have channel 3, which is the input, so the signal generator input at the beginning of the PFN, and channel 1 is the high voltage probe on the output of the PFN, as you can see in the diagram here. So channel 1 is across the final stage capacitor, and channel 3 is right at the source there. So we have a total of 700 millihenries. Each one is 101 nanofarad capacitor for 7 nanofarads total. And using the PFN calculations or calculators online, and playing with this, I've found that the resonant frequency seems to be right around 3.91 kilohertz, and that there are also harmonics that exist around, ironically, exactly at 12 kilohertz, 18.8 and 23.6 again, that I can show you here. So this is known as a Type B PFN. If I could show you the... Oh wait, it died on me. Never mind. Okay, so let's put this here. So I'm going to zoom out a little bit. So notice that there is a load in off of the ground in the picture again here. So there's a variable load there that sees the output signal. And by increasing the resistance, you'll see how that actually modulates the signal. And then adding additional saturation to the first input and first charging choke, if you will, that we can manipulate the wave. So starting at 200 hertz, we see there's already dampened ring down that occurs at the end of the pulse, and we're reading 425 hertz output. So in addition to the 200 in, it's doubling plus some on the output already. So we're going to now go towards the first resonant frequency. And as you see, when we come in, the wave starts to change shape. It increases amplitude. We start to get a little bit of magnification happening from a node building up. We get up to 1.3, 1.4. We have pretty good magnification occurring there. Here we see the classic ripple of the PFN behavior. I'm going to keep going up till we get to 2.5. You can see these nodes start to come out. And then here, as we approach 3.2, we start to see the resonant frequency coming in, and the voltage magnification. Oh, I changed a little bit from what I said. Voltage magnification is highest here. So I have to go down on the next scale. And we've literally got 5 volts in here, and channel 1 peak is 53 volts. And we have some harmonics start to come out already. So this is interesting. So now you can see, if I take the magnet off of the first charging choke, that I can almost tune exactly when the wave, the highest magnification gain from the wave, by increasing it down the line. Not so much at the end. Very little at the end, but very strong effects towards the beginning. So we can use this to our advantage. So let's take a look. We're going to go up now higher. You see the amplitude dampens And then as we get towards 12 kilohertz, a harmonic comes in right there. And see, not quite as high voltage, only 31 volts. I'll keep going up to 18.8. It's about the highest right there, so it's a little less. Voltage 18. And then there's another one at 23, I think. Yeah, right around there. 23.8. Get back down to F-res. So here's the next thing. So this is with a direct connection to ground on the capacitor side of the PFN. So the load in this sense is 0 ohms. Now I have variable resistance in series that I'm going to add 1 kilo ohm to, and you can see what starts to happen. An oscillation, a feedback, a ringing starts occurring back at the input, but it's also reflected at the output. And what we can see is that it is a form of standing wave itself. There's a slight bit of amplitude modulation at each section here that's going. It's easier to see this way. But that noise is kind of being introduced by the load, and if we take a closer look at it, we can see, can't really get it to trigger on that without, so we can see all sorts of noise going on. But let's take it back out and increase the resistance more. We'll see, up to 10K, we get quite a bit there. I'm going to go jump 10 at a time. Now you'll see that the original signal starts really jumping. I'll go far out to where you can see that. And we go 100K at a time. You can see we get this even higher amplitude magnification on the output. If we can get a reading on it. 81 volts total. And then on channel 3 we've got as high as 32 volts. So even the input had gain. 5 volts input turned into 32 because of all the extra stuff happening. So get rid of that noise for the moment. And go back. So we're on 5 volt scale on both of them. It's off the chart, so I have to go down. So isn't that interesting? Now we can go see one other characteristic outside of resonance when we're back to just the ringing. Now we can come back up a little bit because we don't have as much amplitude gain, and remove, oh shoot, can I do it? Yeah, I want to remove one section, basically two stages, and see what happens. I don't know if you could tell that difference. Let's zoom in on the I'm going to take it, so it's off now. I'm going to put it back on, see what happens. Basically, the more stages, the more lag essentially that's occurring. We can look at it here. More lag that's occurring, and when I add 2 more stages, it elongates the dampened pulse. So then we get to the higher frequencies, like around resonance, the difference between that extra stage, there are 2 stages, is enough to throw the whole thing out of resonance, and we have to go back down, back up, sorry, to something like 5.4 kilohertz to get to where we're back to resonance. Okay. Pretty neat, huh? So what do you think? The pulse forming network. Massive gain just from the signal generator. This is the type B pulse forming network where we have this set up. And what's interesting is that there are multiple types, but there's one called a type E, which is very close to the type B, which we see here, but it incorporates mutual inductances. And there are other variations where a choke can exist on as the load. But doesn't this look familiar? The concept is to charge the first charging coil, and then that in turn sets up a DC static charge across the PFN, and then the switching device pulls down the load, similar to how the boost converter would work with the MOSFET. It pulls it down, and then as it's pulled down, then the PFN starts to oscillate at its naturally resonant frequency. And that oscillation is then transduced into the load because of the current. Very cool. Thanks for watching.